how much time does that take to constrain it, not allow it to go past the amount of time we actually have. But how would we calculate total time? What would we do to calculate the total time? Thoughts? How do you know how much time? Say it again? Yeah, exactly, because you don't know how many it's gonna say, but for however many it tells you to make with color shirts, they're gonna take you 4 minutes each. And for however many it tells you to take black and white, they're gonna take you 2 minutes each. So essentially what you're doing is taking 4 minutes times this plus 2 minutes times this, which is a very short formula and easy enough to put in there. But when you start having more of these, it'd be kind of useful to begin using the function that does that same thing. And what function is that? Yeah, sum product. Not that it matters on this really small example, but it might as well get in the habit of doing it because we use sum product all the time. It's the sum product of the time and the number of shirts. Okay. Because what does that do? It takes B7 times B9 plus C7 times C9, exactly what you need to do, which is how much time is it taking you to do that. All right, that will be constrained by the time that we have available to us. Okay, what about the cost? What do we put in here for cost? How do we calculate that so that we can constrain it by the $1,000?
Cost per shirt times shirts made.
Yeah, exactly. And so we can go ahead and do the sum product just like before. The costs and how many shirts. Again, doing the exact same thing that we did with time. It's $6.50 for each shirt, $5.50 for these shirts. So B6 times B9 plus C6 times C9. How about revenue? How do we calculate revenue? Yeah, so we're following that same thing again. Oops. We sell them for a certain amount. We will have, when this is said and done, a plan for how many we're making. Okay. So we get $15 for every shirt. We get $10 for every shirt. That's B3 times B9 plus C3 times C9. Okay. And then, last but not least, profit is what?
Revenue minus cost.
Yeah, revenue minus B16 minus B15. And that's it. I mean, that's it for the model. The model's done. It's, like I said, super small, and we're ready to let Solver solve for us. Could we play around with these numbers and potentially get to the right numbers in time, plugging in 50 each shirt, 100 each shirt, just whatever we need to do? Oh, maybe, but yes, if we had a lot of time on our hands, we didn't have anything else we really wanted to be doing, yeah, we could play around with those numbers until we probably can, because it's small, and because there's only 2 things that we're changing. Okay. But it sure would be a lot easier if we just let Excel do it for us quickly. So we go to Solver, on the data ribbon we go to Solver. Our objective cell is what?
B18.
Yeah, B18, which is profit. So B18 profit, we are trying to, okay, we're business students, we know what we're trying to do. We're trying to maximize profit. Okay. And we're doing that by changing what? The shirts to make, which is in B9C9. Okay. So by maximizing B18 profit, by changing B9C9, the number of shirts to make. But we know we have some constraints. I mean, we would have to, and this again would be one of those unbounded kind of things. So we start adding the constraints, and one of them is the time constraint, and one of them is the money constraint, right? So we want to make sure that the time that it takes us, which we calculated in B13, is less than or equal to the time we actually have, which is a constant that's in D13. B13 less than or equal to D13. We add another one for the cash. We calculated that. The cost, that B15 would be less than or equal to D15. So we went out of our way to calculate that, to constrain it by the $1,000. So you've got B13 less than D13, you've got B15 less than D15. And we could stop there, but we could add what other constraint? If we wanted to. We could add an integer constraint to the shirts. In other words, our original solution to this without an integer is likely going to be, decimal place values on shirts, which of course you can't make, and you're probably close enough, you're probably not stressing over it, and you can play around with it enough to figure out what the numbers should be. If you're the textbook, the number's gonna come out fine, so you never have to think about it, because they worked really hard at that. But in reality, it's not. Integer might not be something you want to add to really big models, but on this one, no problem adding an integer. And it will just simplify our lives if we just go ahead and add the integer. So B9, C9 should be values that are integer values. So B9, C9, integer values. And so, again, you're maximizing B18 by changing B9, C9, subject to time, money, and making the shirt values integer values. This is the way this is for the next, all the way up to through the second test. This is the way this should look. That box checked, simple XLP. And when you solve it, it finds a solution. It tells you what you should do. And our solution is make 72 color shirts, 96 black and white shirts, and we will make a profit of $1,044. Okay, so that's the solution. But again, we're gonna do more with that. But even just answering the questions on here, okay, that's how many shirts to make, that's how much profit we'll make, but what's our binding constraint on here?
Time.
Yeah, it's time, because time is the one of the two constraints, two regular constraints, that you used all that you had. Okay, you have a little money left over, but you used all the time that you had here. And that's easy to see on here. I will tell you, if you ran an answer report, it's gonna tell you an integer constraint is a binding constraint, so it's gonna tell you that. And but I'd prefer if you were picking out one to list as one on the test, that you would explain one of the regular sort of more physical constraints, like time and money and those kinds of things. Okay, so we would be done right now, if that's all we were going to do. But I mentioned to you before, that's not all we're going to do, because we base too much of our bigger models on things that are forecasts and predictions of things that are uncertain, and we really need to look at it and say stuff like this, for instance. Wow, what if I had a little more time? If I had a little more time, I could make some more money. If I could get more time on the machines, and so we might look at that and start to think, what if I did have more time? And then let's say I set up a data table to kind of help me decide, what if I had more time? What if I had 480 minutes and 10 more minutes? I do have 480, but 490 and take that all the way down to like 600 minutes. So what would happen if I had a little more time, a little more time, a little more time, a little more time? What would happen to, and I think the thing we really kind of want to see is what would happen to our profit. So in making the data table, I'll put these inputs here of changing in 10-minute increments, 480, 490, 500, all the way up to 600 minutes, all the way from 8 hours to 10 hours, okay? And let's look at the profit in each of those situations. So I'm gonna make a one-way data table. Like I always make one-way data table. I put the input here, I put what I wanna see as output here. And I go to the data, what if analysis.
Did you equal FB18 on one?
Yes, in H4, I said equal B18, yes. So it's a reference to the cell, it's a reference to that cell there. Now my one-way tables are always vertical, and so I always have column input. And the question is, where would I be plugging these numbers? Well, I would be plugging them right there, okay? I would be plugging them, I now have 490, 500, 510. So I'd be plugging them into D13. When I do that, and I click OK, my profit's not changing at all. It's 1,044 regardless of how much time is in that cell. How do you think that is?
The, cash on hand constraint.
You know, and that's a good guess, you know, because that is like our other big constraint. It looks like we're only $4 away, and so therefore, you know, you really wouldn't be able to do anything else anyway because you didn't have enough. But that actually isn't the case in the way that the numbers would change on the color and black and white shirts. That actually isn't the case. I'll go ahead and just put these in. So when we do one-way data tables, which is what this one is, when we do one-way data tables, we ask Excel to take that number, plug it where we would plug it, and then record how that changes the output, right? That's what we have it do. Why does this one seem like it didn't work? What if I change this to 490? It didn't. What if I change it to 500? It didn't change the profit. Why doesn't it change the profit? Why don't they change? Why doesn't it change the profit? Remember when we traced, I don't know if we did it here, traced the precedents and the dependent cells? That's a little arrow that's showing you what goes into the cell. What impact does me changing this number have on this number? Well, obviously none. Okay. Why? It's not a part of any formula that goes into this number. Me changing that number doesn't change this number. Unless I do what? Like, if I just plug a number in there, it has no impact whatsoever on this, because it doesn't even go into that number. What would I have to do for that to have some impact? Say it again.
Sure, so good.
What would I have to do? Right now, if I want to know what impact having 500 minutes has on this, what would I do?
Did you link that numbers to the formula?
Can you repeat the question?
So let me jump it up to 600 minutes. What if we had 10 hours? What would I have to do right now to see the impact that that has on my shirts, my profit, everything? What would I have to do right now?
Would you have to change your time to print?
Thoughts? I changed this number to 600. I'm curious now what that does to my model, how Excel would say I should break down the shirts and how much money I will make. I'd have to do, what was that?
Did you do another solve?
Yes, okay, I heard somebody say, yes. So if I change this number, that's a constraint value. It's not a value that goes into my formulas that has any direct, you know, impact in the way that you're thinking, change an input, it changes an output kind of effect, okay? If I wanna know the difference of from 480 to 600 minutes, I have to run Solver again, okay? So if I wanna know how this would change, I have to go right back into Solver, run it again. Now I know, oh, now I can make 145 of these, 10 of these, I make $1,277. I have to run Solver again. So, in this data table, for me to get an answer over here, the input value has to be put in. I run Solver, I get a value. Change the input value, I have to run Solver again. And this goes every time the input value changes, solver has to be rerun. Solver has to be rerun. That's not what regular data tables do. They don't do that. They just plug in an input, look at the output. But that's where we need our tool called Solver Table. Solver Table was written by the people that read our textbook, and it creates this table where each time you put in a change of input, Solver runs so you can see the change to the output. Change in input, Solver runs so you can see the change to the output. But we have to get Solver Table. I got it in the last class, but you're gonna need to go get it. So what you need to do is, I forgot to tell you at the end of class last time, go out to Blackboard and download, under software and add-ins, download Solver Table. And the 2016, I don't even know why I have the 2013 still out there. No need for it, and it really is a good changing. I think they're exactly the same. But anyway, download, go to it will go, just do that. Don't do anything else with it. Just get it into your download folder, okay? Go to software and add-ins, download that, get it into your download folder. 16, yeah. I don't think they're any different from each other, to be honest with you, but anyway. Now, once you have that in your download folder, you need to go into File, Options, Add-ins. Okay, that's the same place that we went to turn Solver on in the first place. But you go to File, Options, Add-ins, and that Manage Your Add-ins right here. Do a go to Manage Your Add-ins. Seeing as you're not gonna see these in here right now, so you need to browse for yours, and you'll find it in your downloads, because you just downloaded it. So you better find it in your downloads. You just did download it, so find it in your downloads, and put it in here, check it. It may check immediately, I don't know, but anyway, check it. And when you click OK, what you'll actually get is a new ribbon on your in your menu area. You're gonna get a new ribbon. Now it's gonna be called Solver Table. So I had people with Macs having problems in the last class, not the ones that were running Parallels or Boot Camp, they didn't have any problems, but the people that weren't were having some problems with it. Okay, well, they had problems with it when they tried to run it. Like, it looked like it worked. But, so you can tell me if yours works or not. I had somebody I could ask about that. I need to find out. So, did everybody download it into their downloads? If everybody's gotten that far, now have you added it into Excel and you have a new ribbon? Anybody? It's you know, not good timing, I know, for Andrew to be gone, because he could be helping with this, but he had family emergency stuff, and so he's not here. But everybody good? Everybody want to move forward? Okay, then once you have this, let me get rid of this, because this is not right. That is just wrong. That was not a right thing. So once you have this, instead of you setting up the data table on your worksheet, you actually go into the tool that they provide and you define it in that way. So when you, in your Solver Table ribbon, go to Run Solver Table. When you say Run Solver Table, I will tell you the very first thing it's gonna ask you is, are you on a sheet, and you have to be on the right sheet. On the active sheet, do you already have a solver? Because remember, what I just told you it's gonna do is change an input, run solver, give you an output, change an input, run solver. So there has to be a working solver model on the sheet that you're on. I mean, there has to be. Okay, so obviously ours is, and so you say yes.
Solver Table.
And you keep going. Okay. Yes.
I have Solver Table here, but which part? Sorry. Like, you want me, is it click here and then run Solver Table?
Well, you just click Run Solver Table. That's all you do.
Yeah, it's not working on that,
So, and you're not running Parallels, are you?
I am running Parallels.
Oh, you are running Parallels, because
Yes.
the people I knew that were running Parallels didn't have problems with it before. I have Mac users use it all the time, so I know that it works on a Mac, The difference is whether you have to be running in parallels. I'm not positive of that.
Okay, so you
Okay.
have to do that.
Is yours
Go to our
working?
go to our blackboard.
Are you ready for parallels? Okay. Who's
Mine's-
running parallels?
Mine's working, and I'm not running parallel.
Yours is working, okay, I'm not sure it's gonna continue to work. I'm not sure it's gonna continue to work, I'm not sure you're gonna get the output that you need, but we'll see if it does or not. And yours is, so you're good, sorry if these working. Boot camp or parallels, either one, yeah, so you're running something where you can be running under Windows. You're not, okay, this, you can keep trying to go along with this, I'm not sure at what point you're not gonna maybe get output, which is what people were running into the class at 10 o'clock. So you may have to go try to do some boot camp or parallels kind of thing. So solver table can do the same thing we can do with data tables. It can do a one-way table if you only want to vary one input. It can do a two-way table if you want to vary two inputs. Okay. Well, the only thing we're varying right now, well, actually there is now a specific question on here where it wants us to vary the time. And that's the only thing it wants us to vary is the time, and so therefore we're gonna go into a one-way table. When we go into this dialog box, we're essentially defining what we want to see in the table, okay? So this box is defining what we're eventually gonna see in the table. And the first thing it asks us is, what's the input cell? You know, what's the input cell that we're varying? Well, on the PowerPoint, it tells us to vary the time available from 4 hours to 12 hours in 15-minute increments and see how that changes the shirts that we make and the profit, okay? So that cell right there, D13, that's the cell that contains time. Oh, I did this in the last class too. Cancel this real quick, okay? There is one thing that will make our output on solver table way easier to read, and that's if we name cells that we intend to later see as output. Because if we don't, I'm not saying that solver table won't work, it'll work just fine, but it's just that you'll just see cell references. And the output looks better and is way more user-friendly, interpretable, if you name some cells. So I want you to name these three cells. B9, go up and name it something that sounds like, you know, color shirts. Name C9, something for black and white shirts, and I don't wanna type that much, so I'm gonna do VW shirts. And B18, then name that cell profit. Okay. So again, this is not what makes solver table work, it's just, you'll like the output better if you name the cells that you're going to later use as output. So I called B9 color underscore shirts, I called C9 BW underscore shirts, and then I called B18 profit. I'm sorry, now back to what we were doing. Say run solver table. Do you have a model on the sheet? Yes, I do. Is it one way or two way? It's one way, I'm only varying time. Now I'm back to where I was before. Okay, my input cell is time, that's in cell D13. Input cell is time, that's in D13. This optional name that you give it, again, will be one of those things that you'll just sort of appreciate when you look at the output if you do it. It'll just make your output look better. So I'm gonna describe what this is, it's time available. And then we lay out the parameters as they're given to us on the PowerPoint, which is asking us to vary the time, you know, less time, more time, from 4 hours to 12 hours in 15-minute increments. Now I need to convert my hours to minutes. So 4 hours would be 240 minutes, up to 12 hours, 720 minutes in 15-minute increments. That is coming right off the PowerPoint. So there are 3 ways that you can get input into this, and that's the method that we will always use right there. Okay, we won't do it where we set it up somewhere, and, you know, we're just gonna put in the parameters for what's your minimum value, your maximum value, and your increment. It's the way we'll always do it. Okay, came from the PowerPoint. And then what do we want to see as output? Well, it asked us, you know, we look at this to see what we want to see as output. How does that change the type of shirts that you produce? How much profit, you know, how does that change the profit? So I'm obviously wanting to see this number, and this number, okay? So I go down to the output cells and I just click here, I hold the control, click on C9 and then B18. So I had B9, C9, B18 as output cells. I want to see all three of those things and see what impact it has on all three of those things. Okay, is this set up? D13, which is time available, I'm gonna vary from 240 to 720 in 15-minute increments, and I wanna see what that does to color shirts, black and white shirts, and profit. And my naming those cells is what you're seeing here. And so that's why I'm saying the output's just easier to read. Otherwise, it would say B9, C9, B18. And it is just easier to read and interpret your output if it has names on it. And then where I put time available for D13, well, then time available shows up there. So we can kind of begin to look at this and say, so what is happening? Well, what is happening, interestingly enough, is that if we didn't have much time on the machine, there's a point here where we wouldn't even make any color shirts. We would only make black and white shirts, and that would be what gives us the greater profit, okay? See, the color shirts take twice as long as the black and white shirts do. So when we don't have much time on the machines, we're not gonna make them. And in fact, we don't make them if we have anywhere from 240 to 360. We don't make them. It's not until we hit 375 that we begin to make color shirts. And then, as we do, we had peaked out on black and white shirts at 360 minutes. We start to make the color shirts. That just keeps going up. Those keep going down, okay? Profit, though, all the while is going up because we're making more and more and more shirts until we max out on profit right here. So now we max out on profit, and the whole reason we're making one black and white shirt probably had to do with the integer constraint. It probably wouldn't be in if we didn't put that in there. But anyway, that's beside the point. We practically don't make any more black and white shirts, we make color. And that's kind of interesting. Here's why. Our margin on the color shirts is way higher. If we sell them for $5 more than we do the black and white shirts, they only cost us $1 more. So you could see where we would want to make more of those. It's just that unfortunately up here, that's not best because they take just a little too much time. But once we have enough time to start making them, we'll make more money if we would make more of them. In fact, practically make all. You know, this is, like I said, I think in there only because the integer. However, we max out here at 615 minutes. We have more minutes available to us, and we don't make more shirts. So what's the problem? Why did we stop making more shirts if we had more time?
Because we didn't have enough cash on that.
Because we didn't have enough cash. And this is why we did a model that's so incredibly small, is because those were our only two constraints. If we had time and we're not using it, then it's obviously the cash that's stopping us from going on. Will we know this when we've got oodles of constraints and a big model? No, we won't always know or see it as clearly as we can see it here. Okay, this is just really easy to figure out because, I mean, it's time and money. You know, if we still had time and we're not using it, then we didn't have enough money left. So, yeah, so that's the situation there. Okay, it's moved down and I move it up because I want to be able to see it. Well, one of the other things that Solver Table does for you, besides providing you with the data table, okay, provides you with the data table that, you know, obviously, again, had to run Solver in between every input change. It also provides you with a chart where you can plot this. Now, the interesting thing, what you're seeing here right now, it says the sensitivity of a color shirt, that's one of your outputs, to your input, time available. That's a plot of this column right here. Okay. So when we don't have much time, we don't make color shirts, then we start making them, then we hit that point where we don't have any cash and that levels off. This, I can switch and look at the sensitivity of any one of my outputs to time, my input. So I could change that and see what happens to black and white shirts. Well, They go up at first till we reach that point where we start making the color ones, and then they go down, and then essentially, we don't make them there at the end. What about profit? Well, that's the second column that's being plotted. What about profit? Well, it kept going up and up and up and up until we reached that point that we couldn't make more shirts because we didn't have enough cash, and then it just leveled off. But that one graph can be three different and interactive, and we can turn it into a graph of this column, or this column. So we can do all three columns on there, and we can answer questions accordingly by looking at either the table or the chart, either one. Okay. Everybody good with that? Okay. All right, so move your back over to the sheet that has the model on it. You have to, oh, no, I didn't answer the last question, sorry. I just realized there's another question. It does ask us at the end of that, on average, how much profit results from 15 additional minutes of production time? So, this is what I would do, because it asks on average. I would figure out for every 15-minute increment, how much more money did I make, okay? So I would take my profit at 255 minutes and subtract the profit that was at 240 minutes. So in other words, by going from 240 to 255, I made another $31.50. So that's great. Okay, I made $31.50, yay. But is that the same all the way down? I don't know, unless I do this, okay? And now I can see, no, it's not exactly the same. It looks like it can be as low as 27 or as high as 36 unless I'm missing something. But then you get down here where there isn't, any change because you aren't making more shirts. So when I want to know what the average is, me personally, I would not include those zeros because that would skew that number. I would do it this way. I would look at the average of the ones where there was a change, okay? What you discover is that on average, each 15 minutes produces for you an additional $30.60 in profit. Okay. But because I didn't use that last range, because I didn't want it to skew it, I would qualify it by saying up to 615 minutes. Because after 615 minutes, it doesn't help me to get more time. It doesn't help me at all because I don't have money. So it doesn't help me to get more time. So that's the way I would answer the question. I would say on average, $30.60 additional for every 15 minutes up to the 615. And then after that, it doesn't help me. I wouldn't do the average on the whole thing and put the zeros in there. I wouldn't like that result, And then that allows us, when I said the analysis isn't done when you run the model and say this is what we should do. Because if you know this kind of information, you could also say, some more what if. What if I could get additional time on the machine? Well, what if the person who has the machine tells you, hey, we had somebody that's not going to be using it that originally was, and you can buy extra time on the machine. 15-minute increments will cost $40. Do you want to buy it? No. But they say, hey, 15-minute increments will cost you $20. Do you want to buy it? Yeah, something less than that $30.60 is worth it to you. It's going to give you more profit. And that's one of the things that you can learn by doing some of this other stuff is, if the opportunity becomes available to me, would I be willing to do this? Well, if you don't run some other type of analyses, you don't know whether you want to do it or not. Okay, you don't know, and so this helps you to help make other decisions and see like what if. Okay, now I'm done with the one-way table. Everybody good? Just forgot to answer those questions. If I'm going to run a two-way table, again, when I go to start my solver table, I have to be on the sheet that has the model in it. So I do have to go back to that sheet. And then here was the question. They now want us to vary the time available from 10 to 12 hours. You can't do the whole thing or this would never stop running. Anyway, vary the time available from 10 to 12 hours in 10-minute increments and vary the cash available from $1,000 to $1,100 in $10 increments. Okay, so we're gonna vary two different inputs, and then we're gonna see what that does to our output. All right, so when I say run solver table, it will ask me if I'm on the sheet that has the model. Yes, I am. And then it says, is it one way or two way? Well, we want a variable of time and cash, so this is a two way. So what you have in this dialog box is essentially what you had for the one way. The one way was this. It's just now you have two different. You need to say the input, you need to define the parameters. But then after you've done that for both of the two different inputs, then you say what you want to see as output. Okay. One of my inputs is time. So, oops, I want to take and vary D13, and I'm gonna give descriptive names to these. Time available. My other one's gonna be, I don't care how you put these in, I'm jumping around a little bit here, but I like to type this stuff in first. Cash available, cash on hand in D15. Okay. So those will be the two that I'm varying. D13 time available, D15 cash available. And then I'm just following the numbers that are right on here, okay? Not doing anything crazy. I'm going from 10 to 12 hours for the time. That's 600 to 720 minutes in 10-minute increments. Okay. On the cash, I'm doing 1,000 to 1,100 in $10 increments. And again, that's just coming straight from here. So I'm putting in the parameters I was told. Now, when we do a two-way table, we have time, and we have cash, let's say. Okay. When we put that in, we're able on a regular two-way table on an Excel worksheet that we, develop ourselves, we're able to put in something here, but that's it. We can only put in one output because at every combination of this, we're, looking at this time and this cache, at this time and this cache, okay. The nature of a two-dimensional table, we don't have a choice but to only put in one output. Well, I'm not saying this is like all of a sudden gonna magically make some multi-dimensional thing for us, but in Solver Table, we are able to specify that we wanna see more than one output, and I'll show you what happens. So for the output, I'm gonna choose those same three things, B9, C9, B18. Same three things that we were looking at before. How many color shirts, how many black and white shirts, what profit level do we reach? And the difference now in the way that we're defining it in this dialog box and then it's producing the output for us, and no, it's not making some crazy multi-dimensional thing, it's just simply making 3 two-dimensional tables for me. That's all it's doing. It's just taking and making a two-dimensional table where color shirts is the output, every time and money combination, and then black and white shirts is the output, every time and money combination, and then same thing for profit. Okay. So that's all it did, but because I was defining it in those dialog boxes, it had the ability just to make these 3 for me, automatically. All right. So last time we had a 3-column table, 3 output columns to our table. And when you went in and looked at the chart, your chart could be 3 different tables because you could switch it to where you were looking at this particular output with respect to our input time, the next output with respect to our input time, the next one. Okay. Well, now you have, I think this is not the one. Yep, do that. Okay, so now you have 2 different tables because you have 2 different input values. And this one is looking at the sensitivity of an output to cash. This one's looking at the sensitivity of an output to time. And you can change this from color to black and white to profit. Same thing, color to black and white to profit. So you can look at all 3 outputs with respect to cash, which is one of your inputs, with respect to time, which is another one of your inputs. Okay? But when you do, and you see only one line here, what is that one line? Well, that line right there, let me get up here where you can see this. That one line is looking at the sensitivity of color shirts to cash available, but you always have to specify at what level of your other input. Okay, so that is looking at color shirts sensitivity to cash available, when you have 600 minutes of time. That line that you see on this chart right here is that row. It's that row right there. And if I wanted, I can switch it to something else, not 600, let's switch it to 670. Okay. Now it's plotting that row right there. Where it goes up, it goes back down just a little bit. That's 13 different rows. What I could say, what's the sensitivity of black and white shirts at, and it's going across, it's doing that one right there, which is really an odd one of the more odd one. But let's look at it with respect to 610. There we go. But you see what's happening when you're saying sensitivity of black and white shirts to cash available. Well, cash available is along here, but you have to know at what time level you're talking about. And so that first chart can have 3 different outputs that you're looking at. And then the level of the other input, in this case, there's 13 rows in 3 different tables. So there's 13 levels, three outputs, so you've got 39 different charts. You can adjust this to show you 39 different charts, the 39 different rows of these 3 tables. So you could ask questions like, I don't like this one. We'll do it on the next one. We'll ask a question on the next one. Because this one's goofy. When you're looking at the other chart, which is the sensitivity of any one of the 3 outputs, to time, and time's down here on the x-axis, you've got to say at what amount of cash are we talking about. And so this that you're seeing right here is the sensitivity of colored shirts to time is on the x-axis, at $1,000 of cash. That's that column right there. Okay? That column, which just goes up after a couple and stays up high, that's that. So I'm gonna try to get something on here I can see at the same time. So let's say I ask the question. See it? Yes. Okay. At what amount of time would I not make black and white shirts if I had $1,080 in cash? That's the whole question. At what amount of time would I not make black and white shirts if I had $1,080 in cash? Okay. So the thing I'm looking for is trying to find the sensitivity of my output, black and white shirts, to the input time. Okay. So here it is, black and white shirts. Okay. Sensitivity to time. When I have $1,080, so I choose 1,080. Okay. I'll get you that real quick. I put black and white up here, 1,080. That's what I'm seeing here. When do I not make black and white shirts? At 670 minutes or more, I don't make black and white shirts, which means I'm making all color shirts, but anyway, it means I'm not making black and white shirts. That's the column right there that's being plotted right here. I know that it starts to sound more complicated, when you try to manipulate the stuff on the two-way tables as opposed to the one-way. You have to just slow down and read it really carefully. What exactly is it asking me? You know, it's obviously asking about some output. It's sensitivity to one of the inputs, but it has to give you the level of the other input. Okay? And then you have to choose which chart. So can you answer that question here and answer it there? Yes, but you will be asked to set up the chart so that it reflects the answer that you got out of the table. Okay, so that the chart is showing you exactly, you know, which column you were plotting to get that answer. So you will have to do that. There is a question on this PowerPoint that is real vague. It says, how much does each additional $10 give you in profit? For each additional $10 that you have, how much more profit would you make? Well, the problem with that is it doesn't tell you at what time level. If it had said, if you had 720 minutes, well, then we kind of do what we did before, which was take the profit at $110 $1,010 and subtract out the profit when we have 1,000. It's $12.50 extra. We do this. We'd average it. I don't have to do that because the average is right there. We'd say it's $13 and wow, that's fuzzy. $13.15. You know, so we could do that. However, that actually wasn't in the question. The question didn't have at 720 minutes. So exams are going to be very specific on what I'm asking. Exact, you know, choices of things. PowerPoints aren't always, because sometimes there are things I want us to talk about in class, but I don't want to have the specifics. I'm going to talk about why we're using the specifics that we are. This one really was just more of a, you know, just to kind of recognize you do have to have a lot of information, because the only other way to go about that without that information might have been row by row to have taken the differences, the incremental differences, then average those columns, then average the averages. Okay, if you really want to do that, which I wouldn't ask you to do. But I'm just saying that would have been, you know, a way to go about that with limited information. That would have been a way to go about it. Either that, or you just make assumptions and say, well, I'm assuming you mean it 720. But a test wouldn't do that. A test is going to be very specific on what I'm asking you to do. What you do have to be able to set your charts up to reflect the question that I'm asking. Okay? And you know, you can double check yourself by just reading a table. You can do it whichever way you want, but the chart will have to reflect the question. And it seems more complicated on these two ways. It really is just a matter of slowing down and thinking through each part of what it's asking you to do, you know, to put out there. I have a couple, any questions about that right now? So because we have a little bit of time, I'm gonna just tell you real quick. You have 5 questions on that test that's a week from tomorrow. You have a data table question, really just from the material, but then it moves into things that are in the textbook, chapters 2 and 3. You have sort of a math model question, a time value question, but then when you get to this stuff, I separated the product mix model from the solver table question, just for this test, because it's the first time that you're doing solver table. So you'll have a product mix problem, you'll solve it, okay, but you won't be asked to do a solver table on that one. Then I'll have one where I have set up the model completely and you're asked to do solver table because I want to test only solver table. If I've had you do it and yours isn't right, and that just gets more complicated, it's just easier if I know that there's a working model and I ask you to do solver table, I'm specifically testing your solver table ability that way, you know, without it being complicated, but maybe not having been able to do the model or get it right, okay? That's why there's 5 questions, because really in some sense I was sort of splitting the question out into 2. It won't be like that on the second test. On the second test, when we run a model, even a larger model, we'll be asked sensitivity analysis questions afterwards. You'll run solver table right afterwards. We'll assume by now, you know, by the second test that you've been using it, you know it, and everything is good. But anyway. Okay, so that's the way that'll work. I don't think I have the review sheet out there yet. I need to put that out there. It's just telling you what questions are on it and what chapters it refers to, because the material is is this and the book. But anyway, I will get that out there. So we will get to do more on Tuesday, more product mix and sensitivity analysis with solver table. There'll be 2 more models that we do, kind of one very unconventional like one, and then one that's just a little larger. And then on each we'll do sensitivity analysis. And then on Thursday, we'll review for the exam on Friday. Okay, so we will get, so we've really introduced all topics that are on the test. We're just gonna do more with it on Tuesday and then review on Thursday. Sign up at CASA if you have not done so. And any questions? No, we're gonna get out a few minutes early then. Just have time to work. The IA's hours are gonna be